In today's video, we are going to cover how to set a custom signal handler using C++ in Linux. By using a custom signal handler, we will be able to cleanly shut down our application and clean up any resources that may have been used while the application was running. As part of this process, we will also configure pigpio to allow for the use of a custom signal handler, as that library has some special steps. So the first thing we're going to cover is how to use the signal handler and getting it to work with pigpio. So the way that you get a signal handler set up in Linux is you have to include this signal.h file. Then you define your signal handler function. That is the signal handler that you want to run when the signal is received. It'll tell you which signal was actually generated, and then you connect the signal handler to a specific signal. If you go to the Linux documentation, you'll see that there are a number of signals that you can connect to run your own signal handler. So we're just going to connect to sigint and have this function run. And what we're doing is we're setting a global variable is running, and then when the signal is received, we're going to print to the screen and then say that is running is false. So when we go down to our main section here, we are looking for the is running variable to be true. Otherwise, we will exit the main while loop. The rest of this code is just the same flash LED functionality that we saw in my previous video. Go check out that video if you haven't seen it already. And we're just flashing this one GPIO pin 26. So let's try running this and seeing what happens. Okay, so when we look at the circuit, it's flashing LED on GPIO 26, and then we try to shut it down. We see our message didn't get printed, and if I run it again and wait for the LED to turn on, we see that the LED didn't turn off, but our application now at a line that says to turn off the LED pin when the application is shut down. So what is going on here? Well, it turns out that pigpio has its own internal handler. So this message that you're seeing here with signal handler unhandle signal 2 is from pigpio. It's not what Linux would normally print on its own. If we look at use signal handler 2, we need to disable the internal signal handler from pigpio in order for it to function. So let's go and disable the internal pigpio signal handler and see what happens. The way you do that with pigpio is that you can use this config get internals, get the configuration, or it with the no signal handler bit to turn that off, and then we set the new internal configuration. So let's go run this application. Signal 2. Oh, I'm gonna hit sudo. We run it. LED is flashing. We shut it down. And notice there's no message this time. So normally Linux, when you hit the signal Control-C or send that signal, it doesn't print anything to the screen. Whereas previously with signal handler 1, when we hit Control-C, we get this output. This output is being generated by pigpio. So we know we disabled it correctly because we no longer get that message. Now let's go back in and try to add our own signal handler. So again, we disable the internal pigpio signal handler, but this time we add back in our own And what should happen is we'll print this message. We will set the is running variable to false, so the while loop will exit, and then we want to turn off the GPIO pin explicitly. So let's make this application, and then we can run it. Sudo again, and we'll see the LED is flashing. Now we wait for the LED to be on and then shut down our application. It should turn off, and we should see this message that says receive signal is shutting down. Receive signal is shutting down. It shuts down, and the LED is off. Now you'll notice that it took a little bit of time for the application to quit successfully before the prompt was up again, allowing us to do something else. And that is because of the way the application is written. We set the flag is running to be false, but we still have to wait for these two function calls to execute before we fall out of the while loop. So it could take up to 2 seconds for the application to end, because if we Control C right as we turn on the LED, we still have to wait 1 second, turn off the LED, and then we can terminate. So this line here, where we actually explicitly turn off the LED, isn't needed based on the structure of this code, because we will always run through the contents of the while loop. The very last thing that will happen before the application exits, or before the while loop exits, is turn off the LED. So we don't really need this, but it's always good practice to explicitly clean up or close out anything before you terminate, so that you don't have to worry about what you're doing inside of the while loop and relying on that to leave your application in a good state. So that's how we set up a custom signal handler and configure pigpio. If you found this video helpful, please like, share, and subscribe to the channel. And if there's anything you would like me to cover, please let me know in the comments. That's it for now. Talk to you soon. Later.